Hello, this is Madison Mayfield, and I'm excited to kick off our individual YouTube presentations. If you're watching this, that means I actually figured out how to upload it. My topic, business intelligence, data analytics, and visualization, will fit nicely with the materials and the discussions on the Netflix case from last week's module. So let's get started. Business intelligence is an umbrella term that includes the applications, infrastructure, tools, and best practices that enable access to and analysis of information to improve and optimize decisions and performance. I included the quote from Napoleon, "War is 90% information." And I know it might be difficult to compare European wars to business intelligence, but the underlying idea is that information is vital. Having information is a tool or a weapon. And especially nowadays, having data is considered having an economic asset like currency or gold. But having the correct information can make all the difference. So how did this all start? The term first appeared in a encyclopedia in 1865 and was used to describe a banker, Sir Henry Furness, and his success. It was said that he maintained complete and perfect records of the happenings going on in Europe during this time. Unfortunately, he used this advanced knowledge to become a corrupt financier. In 1958, an IBM scientist published an article that truly described the core of what BI is today, a way to quickly and easily understand huge amounts of information so that the best possible decisions can be made. An international conference titled the Multi-Way Data Analysis was held in Rome in 1988 and was a landmark in simplifying BI analysis. This is following IBM's invention of the hard disk that revolutionized data storage and finally gave companies an alternative to storing data on paper. The 1990s were considered the first generation of BI. However, it would typically take weeks of IT work and coding to create a series of reports. And due to the use of APIs, single discrepancies in the data ultimately impacted final figures, proving to be extremely costly because, as a result, the time spent checking the data wasted a lot of resources which could have otherwise been invested elsewhere in the business. The 2000s marked the second generation and also the rise of standardized data warehouse. There was also a number of self-service BI tools that came to the market like Tableau. This somewhat helped the backlog problems, but with the increasing of interconnectivity of the business world, it meant companies needed real-time information. This was also the point where BI was no longer an added utility or advantage. It was becoming a requirement for businesses to stay competitive. Today, BI tools are currently designed with specific industries in mind. Think healthcare or law enforcement. This growth, known as software verticalization, has contributed significantly to increased adoption of BI. More platforms are available for users to explore their data on their own. The global big data revolution. This is happening now because technology enables firms to gather extremely detailed information from and propagate knowledge to their consumers, suppliers, alliance partners, and competitors. And just two numbers I want to point out on this slide. 15,000 data science professionals by 2020 and 200 million into big data research projects. Data analytics, the practice of examining large databases in order to generate new information. We are literally drowning in data. 2.5 quintillion bytes of data are created every day, so much that 90% of the world's data has been created in the last 2 years alone. The 5 steps of data mining. Identifying the source information. You need to check different data sets and different collections of data. Picking the data points that need to be analyzed, extracting relevant information from the data, identifying key values from the extracted data set, and then interpreting and reporting results. I wanted to include the top 10 companies using data analytics, just to give you an idea of what kind of objectives companies have in mind when they go through the data analysis process. Amazon is of course a huge one. They use advertising algorithms. American Express, they actually use data to analyze and predict consumer behavior. They're able to forecast customer loyalty. They're also able to predict within a 4-month time range of when an account will close. BDO, they use data to identify risks and fraud during audits. Something like this used to take numerous interviews and hours of manpower, but they've been able to streamline that process. GE, they use data from sensors on machinery like gas turbines and jet engines to identify ways to improve working processes and reliability. Starbucks, they actually use data to determine potential success of each new location. People joke there's a Starbucks on every corner, but they actually consider the traffic, the demographics, and the customer behavior before they put up a new location. Top big data use cases. As you can see, customer analytics, experience analytics, and risk analysis is what most companies are trying to get information on. Getting data to support smarter and more targeted marketing is also a big one. There was a survey done of execs at Fortune 100 companies, and this survey has been done every year since 2012. This was the first time that a near majority of 48% report that their firms are achieving measurable results from their big data investments. 80% of execs characterizing their big data investments as successful. So a shift that we're seeing now is that companies are not just using data analytics for cost cutting, but they're also undertaking offensive efforts that are explicitly intended to change how they do business. Visualization, showing the stories in data through statistics, design, aesthetics, and code. Now that we have all this data and know how to analyze it, how do we present the findings in the best possible way? I picked this quote, "If the statistics are boring, then you've got the wrong numbers," because the audience and the type of information need to be taken into account before determining how to visually present your findings. 90% of information transmitted to the brain is visual. 60,000 times faster our brains process visuals compared to text, and 40% of nerve fibers link to the retina. 36,000 visual messages registered by our eyes per hour. I picked this chart to highlight just because it stood out for me. The Invisible City, it's a chart that shows what 100 million calls to 311 reveal about New York, common complaint types based on time of day. This chart is colorful, it's interesting to look at, and it has a clear message. You don't have to look at it too long to see that big pink band that's the noise complaints, and how it gets wider into the evening and the early hours of the morning. These charts use real pictures, and they have a big impact on people. Being able to see real objects or people will help the message stick in viewers' minds and will create an emotional connection between the subject and the viewer. Not all charts have to be extremely serious or even useful information. Sometimes we get so used to seeing charts on poverty rates or increase in heart disease. So I wanted to include this chart that's absolutely meaningless, but has data from a study done on the amount of beards per baseball team. Data visualization. It can reveal trends, comparisons, or processes. It can use real images, animation, or metaphors. I love this chart comparing fruit to planets because it takes something that is so common to give us a concept on something we would never be able to otherwise relate to. The dark side of BI. With huge data sets and fine-grained measurement, there is an increased risk of false discoveries. A statistics professor at Stanford described it as seeking a meaningful needle in massive haystacks of data where many bits of straw look like needles. Biased fact-finding. This is specifically looking for the data that supports your theory or knowing what the results should find. Privacy concerns. While personal data remains a small proportion of big data, there is still suspicion and concern amongst the public. And in the US, there is no single comprehensive federal law regulating the collection and use of personal data. So what's next? Recently, execs from companies that are leaders in data analytics got together to share perspectives on their current biggest challenges, which gives us an idea of where companies will be moving towards in the next few years, the next frontier of BI evolution. Tool specification was a big one, customizing based on industry and company, expanding self-service options, and improving visualization. Another big topic was privacy. Companies feel that giving consumers more control can help gain that trust. just by placing that control back in the hands of consumers, creating some sort of opt-in model. Another topic was talent. Companies need to figure out how they're going to get and keep the talent necessary in order to continue to drive data analytics forward. There's a short supply of the employees that they need because they really need translators who can drive the design and execution of the overall data analytics strategy while also linking IT and the business unit teams. At this point in the evolution of big data, the challenges for most companies are not related to the technology itself, but to cultural challenges, organizational alignment, resistance, or lack of understanding. At this point, I just want to leave you guys with a few discussion questions. With so much innovation, do you think there are any areas still lacking BI tools or adoption? What are the next steps in relation to data protection? With this flood of data, what solutions should companies look to in storing their data? At this point, I just want to thank you guys for listening to me talk for this whole entire presentation. Here are my references cited. Thanks again, and I will see you on the discussion boards.